Yes, Raghuvel, did you watch the lecture which you missed?
Yes, the pseudo force and
Hmm?
the pseudo force one, right?
After that, there are two lectures. Only
Yes.
one lecture. So far we studied the laws of motion. Friction is not something going to add extraordinary. It will add one force, which we call friction force, and we have discussed the idea of friction in the beginning of the laws of motion itself. But I'll give you some more mathematical formulation of the friction and why we study friction, because the assumption that the surfaces are smooth is not realistic. I mean, of course, you can decrease the friction, but you cannot make it zero. So in real life, friction will always occur. So it is good to know that how friction controls certain mechanical stability of things and how it is important in many ways. How it enables motion in particular. So, for example, if you are able to walk, or if you're able to ride your bicycle, or even I mean motorbike or car, all these are enabled because of the friction. So it is not the car is capable of moving forward. It is not that you are capable of moving forward. So you rely on the friction to allow it to move forward. And the way you move forward is very interesting theory itself. That you try to push the ground backward, but the ground will hold your, I mean, foot at a place, and it will prevent it from going backward. And then you kind of fall. You kind of fall. Your body actually falls forward, and then you balance on the next foot. So it is like a you take your foot as some sort of kind of a support on which you fall. Your entire body mass is fall, and the next foot will try to balance it or hold it back, and you make some very subtle movement which you don't realize, but actually you're doing that thing. And to realize more, if you go back to the childhood, a child when tries to walk, he lifts the foot, and then while putting it back, he falls. So he has not learned how to balance the body weight on the 2 foot. So it's a process of learning. It's a neuro exercise in which your brain actually understands the variation of pressure over the area of the foot, and then you kind of bend your foot. I mean, you don't realize. I mean, of course, intentionally we don't do all this calculation. It is kind of inbuilt in the mind of every child. So it's a neuro exercise. So they learn over the time, and they keep on improvising their you can say shift of body weight, and they know how to manage it. Okay, so it means they exert pressure, force somewhere. They create some required normal reaction, which can create not just force but also torque. What we need to understand that our body itself is a mechanics, a complete mechanics. So when in a kindergarten, or maybe in the beginning of the schooling, they talk about the posture, that you must keep the posture that way, because see, our body weight is kind of controlled by the spinal cord, by the bones, and they need to be in a particular shape to exert the least force, and that's how you can increase the, you can say, the working or the longevity of those parts. So we ignore the mechanics, okay, and we believe that the body is acting in a different way. No, it's like body exactly works as per the laws of physics. I mean, there is nothing beyond the physics. So every activity which is happening, every motor activity, we call something called motor activity. We do have motor cells, right, which enables the movement of the parts of the body. You bend your finger, and then there is a unsaid spring kind of nerves, which kind of connects muscles, and then when you try to move, your brain is kind of signaling to move, and the muscles will contract itself. And the contraction occurs by the virtue of the charge accumulation. So your body will throw the charge there in no time. All this thing happens in a very small time interval. So the brain wave will, kind of give signal to it. It will create a charge, and the charge will create the attraction, like Coulomb's law, and that will help you, moving it. So in a way, the brain is controlling this flow of charges. I mean, there is a way which is, making it possible. So your body itself is a very giant, you can say, um, not just computer, it's a giant mechanical system with extreme movements. I mean, there are many things happening, and of course, we don't realize in our day-to-day life. So we take everything as granted. Okay, but the thing is, everything is working because there are many parts which are functioning accordingly. So you have tendon, you have muscles, you have nerves, you have so many things, and they all connect, they all communicate. There is a way to communicate also between the various body parts, between the various cells. These things are always there. Okay, so now we are learning the friction. Friction is something really, really interesting. Uh, Basically, it is the, okay, I have explained. So eventually the electromagnetic interaction of the atoms near the surface, okay, where you touch. So if you are imagine standing on a ground, then the foot, the base of your foot, I mean, that atoms which are infinite, and the atoms the ground is made of, maybe the tiles. There is an interaction between those atoms. So in a way, you are kind of levitated. Okay. But that levitation is so close that the brain cannot understand that you are actually levitated. So there is a like nanometer gap between, let's say, you and the floor. And that nanometer is too small. Even light cannot pass. So you can see there is no light across when you touch something. And you end up seeing that, okay, you're touching something. Okay, so the touch is again a physiological way to express the force which you feel, okay, due to the interaction. So these things are happening. Friction, I explain in two different ways. One is the friction because of the surface geometry, like how the surface is at a very nanometer scale. If I would like to see it using a microscope, how the surface is, you can see there are many like mountains. You can say there are nanometer scale mountains, and the mountains are kind of evenly spread throughout the surface. And the other surface is also having the inverted mountains. You can think that as a inverted mountains. And when these two mountains try to move across each other, then they kind of oppose, they kind of restrict the movement. And that restriction, which is due to the kind of, hindrance the mountains are creating for one mountain to cross the other mountain, that opposition we are terming as friction. So imagine that when you try to move something, you break mountains in the due process. So some mountain will be, climbed by the surface, some mountain will be broken by the surface, and therefore you do a lot of work in breaking those mountains and then trying to move across it. Without your realization, the wear and tear is happening. So the surface will rub away. Okay? It will kind of tear away. After long usage, you can see it will become it will lose the shine, it will lose many things. So we don't realize, of course, because it is happening at a scale which is difficult to perceive. Okay. So the friction is always there, and this geometrical, the mountain and the inverted mountain idea of friction, we call as kinetic friction, because you break the mountain when you actually move. But when you're not able to move, when you're kind of stuck between the mountains, the mountain and the inverted mountain, wherever they touch, they glue together. And this ability to glue together, we call the cold welding. So there is a concept of cold welding. It's like they interlock, they kind of lock with each other. And when you try to move for the first time, I mean, let's say motion has not started, you're just trying to move. You have to break the glue actually. The motion will start, then the mountain will be broken, and then that's a different motion altogether. When there is a tendency to move, you're trying to push it, but it is not moving actually. Although we say that it is not moving, but on a nano scale, if you go to pico scale, there is a movement, but there is no movement at nano scale. I mean, there is a different layer of movement. So it's like some lateral shift. You kind of you have a sponge, and if you press it, the sponge may not move, but it can tilt at least. Okay. So that kind of thing is happening. So you have to break the glue. So to break the glue for the first time, you have to exert certain amount of force. And that certain amount of force, before any force below that certain amount, which we are going to name as limiting friction. So any force which is not up to limiting friction will not let you move. Okay. Because that is going to be balanced by the the forces which they can create. It means what you apply, they will also apply, and they will hold you there. So that's the whole idea of static friction. So static friction is that cold welding stuff, and the kinetic friction is that the breaking the mountain. So these are two imagination you can create your mind. So if you have seen the sandpaper, it will have the very coarse surface. You can clearly see it's a rough surface, and we take that surface to rub the wooden objects, metallic objects, depending on the coarseity. We can have a different gauge actually, that what gauge of sandpaper you want to use, depending on what kind of smoothness you want to create. So friction is, of course, useful in many ways. I mean, it enables the motion in many cases. Of course, all the stuff which we do for polishing, they also use the sandpaper of different grade, very fine grade sandpapers are also there, which can create very smooth surfaces. Then the more coarse papers are also there for the different purpose. So we have all those things, and there you see the roughness, but in our day-to-day life we don't see the roughness. Okay? So our perception of roughness is not very much intact. We don't understand. Sometimes a very smooth surface, we believe that will have no friction, but that's not the case. So if you have a very smooth tiles, and if you want to walk on a hard sole, if you have a hard sole, it is difficult to walk because the friction is so small that it will kind of not hold your feet. So your feet will kind of slip backward, and therefore it's difficult to walk faster. So now we have the rubber sole. The rubber sole will create a very good grip. So there is some concept called grip. So on a very smooth surface, the rubber soles are really good. They create a grip because they kind of create a vacuum. Okay? So they push out all the air, and then they create a vacuum. So it kind of glued in a kind of suction way. Okay? So that is also, in a way, it creates a kind of grip that we can also term as friction. Okay? So friction is an idea. Okay, the idea that you can oppose certain relative motion. Okay? But friction is not the idea which opposes the motion as a whole. Okay, so sometimes people say that friction opposes the motion. No, we are able to walk, we are able to drive, run because of the friction only. So it is not opposing the motion of the person. So what it opposes is the motion. No, it's opposes the relative motion of the surfaces, like one surface over the other. So when you try to move forward, actually you push the ground backward. And when I'm opposing it, so how I will apply the force to oppose you? How the surface will exert force on your the base of the foot, the sole of the foot? In which direction? Will it apply force backward or forward? Common sense. Think about it logically. If you're trying to move, then how friction should act? In your
So
directional
forward.
motion or against the motion?
Against the motion.
Which motion? Your motion or the motion of your foot? See, friction
So
should not
motion
be
of the
looked
foot.
for the body. Friction is only looked for the surface. So that's again a very um, common confusion or a dilemma, that where we should look for friction. So when you're dealing with the block or the wedges, it's a simple. But when you talk about the human, okay, the wheels, you don't realize how friction is acting. And you will simply say that it opposes. Like, have you seen it is opposite? How you say opposite? Like, do you have any realization? Have you seen it? Have you felt it? Or are you just, kind of restating the very common statement which you have read somewhere in the class 10th or 9th? What are you doing? Are you really understanding the friction, or you're just saying because you have no sense of saying? You're just saying because you have read somewhere. It opposes the motion. Have you experienced that it opposes the motion? Do you really know that it is opposing? Tell me, yes or no? Do you really know? Do you really believe? Tell me, guys. Do you all believe that friction opposes the motion? Tell me, yes or no? Tell me. I mean, I want to answer in yes or no, please. Tell me, Siddhant, what do you think? You really felt in your life that friction is opposing my motion? It is pushing me
Sir, it
backward.
depends. Sir, it depends.
No, when you are walking, do you feel that friction is opposing you? It is kind of
No,
pulling you
sir.
back. So
It
who felt it?
favors.
Who felt it? Tell me who felt it. I don't know why people are saying this, because I'm not getting any idea. Like why people are saying this without realizing, just because some sort of ma'am has said in the class and you're taking this on heart. So today we are going to do one simple experiment. Okay, so what we are going to do is we are actually going to walk. Okay, so you all have to walk few steps. I'll give you 2 minutes. Stand up, go, and walk really slow, and try to feel that how you walk, and then come back to me after 2 minutes. You all have to walk actually slowly and feel the foot, not the body. Feel where you're touching the ground. Okay. Try to feel it and then come back to me after 2 minutes, and then we'll discuss. Okay, you all go. Walk enough to understand. Everyone, go and walk. Okay, you all are back. Hello.
Yes, sir.
Okay, you all are there. So you all walked. Chigant, you walked.
Yes, sir.
President, sir, you.
Yes, sir.
You're with.
Yes, sir.
Tell me your experience. How you, what you what doing, while walking. What you exactly, what are your various steps? What you do exactly?
Pushing the floor backwards.
Yeah, but when you're pushing the floor backward, so you're trying to move your foot backward, right? You're trying,
Yes.
but it is not going backward, right?
Yes.
So who is holding the foot?
Friction.
So do we have any option?
No.
So the only force holding a foot, preventing going backward is friction. And then what you do next? So you are careless because your foot is, supported by the friction. Then you try to move forward. No, but you don't move actually. If you look carefully, you simply fall. Your hip will turn, or your body will try to fall forward, isn't it?
Yes.
So you fall and then you try to balance on the front foot, right? And when you try to put the front foot, you kind of push the ground forward, right? Do you
Yes.
realize this?
Yes.
But again, friction is stopping you. So if you look carefully, while moving forward, the friction is actually acting forward. But when you try to stop your front foot, it creates friction backward. And then again, you push it backward to make the next movement. It is happening in a cycle, which means you have a series of steps which you complete and then you repeat. So it's a repetition of body movement, which is very interesting. Friction is a chapter which is very conceptual because one cannot do it mathematically unless that emotion, organic thinking, you are not able to develop. You may be able to solve some of the typical problems of books, but as you go towards the higher difficulty level problem, there I think it is more of the realization which helps than simply solving the problem. So the realization is really important. Okay. So now tell me, is friction acts opposite to the motion or towards the motion?
Towards.
Okay, so it is not opposing the motion, isn't it? But it is opposing what? It is opposing the motion of the foot, isn't it?
Yes, sir.
But is it opposing the motion of the body?
No, sir.
No. So friction never opposes the motion of the body always. It may oppose sometime, but it always opposes the relative motion of the surfaces in contact. So that is the beauty of friction. It only opposes the relative motion of surfaces in contact. So that's the whole idea of friction. Okay. And as I said, friction will have two types. Which two types? Static and kinetic. So imagine when you were walking, were you breaking the mountains or holding the mountain each other? What you felt? Tell me.
Sir, could you repeat?
So when you were walking, the nature of friction was kinetic or static?
Sir,
What you
kinetic.
felt? So what is kinetic friction? When you break the mountain, right? Isn't it?
Yes.
And to break the mountain, you have to rub the two surfaces against each other, right? Yes or
Yes,
no?
sir. So static.
So tell me, were you rubbing the surface while walking?
No, sir. No, sir.
Tell me anyone. You all realize
Yes, sir.
what I'm asking? Persons are there?
Yes, sir.
So do you realize?
Yes, sir.
What you realize?
That we are not rubbing the surface while we
Yeah, you were not rubbing the surface. You were just keeping there only, right? But then you lifted the surface, like you simply lifted the foot. You lift, you just remove it, and you lose the contact. And then because your foot is in air for some time, there's no friction, there's no touch actually. Rugved, do you understand this? Do you realize this? What I said? Hello, hello. Rugved, I'm asking you. Are you there? Hello, hello. Rugved, are you there? May not be there. Okay, he is still working maybe. So the idea is, if you have the realization, it's very simple. Let's say if someone is washing the utensils, which friction you think? Is static or kinetic?
Kinetic.
Kinetic, definitely. Because
Kinetic.
if it is static, will it ever clean it? No,
No, sir.
impossible. So imagine if someone is shaving, okay, which friction you think? Is static or kinetic?
Kinetic.
Because the razor move over the surface. So one surface and other surface, one move over the other. So whenever there is a relative motion between the surface, then only kinetic will come. But imagine you are riding bicycle, or not a bicycle, not riding. Let's say you are sitting on a bicycle, and someone is riding. Let's say you're sitting on the carrier. Maybe it's a earlier we used to have a carrier in bicycle also. So now the person sitting over the carrier, there is a contact between the person and the surface, the carrier, right?
Yes,
And
sir.
as the person goes forward, does that person moving relative to the carrier or moving together with the carrier? What do you think? Is it a relative motion or it's a motion together?
So together.
So which kind of friction we can think of?
Static.
Static or kinetic? The answer is
So static.
static. Definitely, it's a static friction. Static friction comes whenever the two surfaces in contact having the tendency of motion, but they fail to move separately. They want to move. So now the question is how we know that they want to move. It's very simple. When you are sitting on a bicycle and the person who is riding the bicycle, imagine you're not holding anything. You're just sitting, okay, not holding anything. As bicycle will try to move forward because the person who is pedaling uh, will have a, will rotate the wheel, and which in turn the wheel will experience the friction force from the ground, and the ground will kind of push the bicycle forward, but no one is pushing the person sitting on the bicycle forward because the person is not kind of glued to the bicycle. Person is not riveted, not hinged to the bicycle. Person is simply sitting over there. So the obvious question is who can move the person? Bicycle can move because of the ground friction, but who is moving the person? Because person is not holding anything. So it is a friction, isn't it? So the carrier is trying to move forward, but the person, because of its own inertia, will try to remain there. So there is a tendency of a relative motion. It's obvious, but because there is no relative motion in reality, that means you can say that friction is doing the job. Of course, the bicycle must accelerate in that way. If bicycle is moving with a speed of 10 kilometer per hour, the man is also, attaining that speed. So man is also moving with 10 kilometer per hour. In a way, bicycle is not accelerating. Bicycle is simply moving with 10 kilometer per hour, and the person is also 10 kilometer per hour. So because the inertia says that the person will have the tendency to keep on moving forever with 10 kilometer per hour, and bicycle will also have the same. So in terms of physics, there is no relative tendency because they have the same speed, and I'm not trying to change my speed. So the bicycle and the person will always maintain that speed because of the inertia, and therefore the tendency will never develop. So just because something is touching the other surface, it doesn't mean friction will come. Friction comes with some condition that the two surfaces must be in contact. Yeah, that's a prerequisite you can say. And then they should have the relative tendency of motion. And it is best if they have actually relative motion. I mean, if there is a relative motion, then no doubt there is a friction, and that friction is kinetic friction. But in many cases, which are the difficult situation, it is difficult to realize that there is a tendency of a relative motion, but there is no motion. For example, if I give you a simple example, if you have a inclined plane, and now it's a rough plane, and there's a block effect. Now imagine there is no friction. I mean, don't consider friction. What will happen to the block? Will it try to move down the plane, or will it try to remain there only? What do you think would be the tendency, assuming there is no friction? If I ignore the friction, then do we see any tendency? You have to do this mental experiment. What do you think? Block will try to go down, yes or no?
Yes, sir.
And who will bring it down?
So
Gravity.
Yeah, so the component of gravity will try to bring it down, isn't it?
Yes, sir.
So tendency is there that you can realize. So block will try to come down because no one is there to stop it. And now if I'm saying that block is not moving, then what you will say? Who must be holding the block? If block is not moving, then how this could be
Friction.
possible? And then the common sense says that how the friction must act to prevent it going down. How the friction should act on the block? The friction on the block will be acting in which direction?
Sir, opposite to the component of gravity.
Correct. And what will be the value of friction?
Mg sin theta.
Very good. So to keep the block at rest, the friction must be mg sin theta, because you are supposed to balance it. Will it be more than that? Or less than that? Or exactly equal?
Equal.
Only equal, because
So-
why it will more? Because if it is more, then it will go up, which is meaningless. Like that physical event will never happen. And if it will go down, then of course friction will be lesser than the mg sin theta. So if it is not moving, if it is not accelerating, then we can say that friction is responsible for stopping a block, and it is trying to oppose the tendency, and not trying, in fact it is able to oppose the tendency created by the gravity. And that force we can easily see it's mg sin theta, isn't it? So you all realize that this friction is which friction? Is it static or kinetic?
Static.
So for friction to act, we always need to have the static, we always need to have the contact and tendency both. If there is the contact but there is no tendency, then is it possible to have friction? Tell me yes or no. So imagine there is a table and there is a block. Now tell me, do you feel that there is a tendency of motion for the block over the table? Do you feel? Do you think there is a tendency for the block to move?
No, sir.
Everyone tell me yes or no.
No, sir.
So contact is there, surface is rough, also maybe the table will have a sandpaper. So surface is definitely rough. Block is kept, but there is no tendency actually. So the problem is, without tendency we cannot think of friction. So neither it is moving relatively nor there is a tendency. And whenever this kind of thing happens, then we say, okay, there is no question of friction. So how much friction is acting on the block right now? So friction on the block is how much?
Zero.
Hello. It is 0, right?
Yes.
See, we need to have some tendency. No? Without tendency, how we can talk about friction? Friction only comes when the surfaces in contact will have the tendency to move. Okay. So these are three key points about friction. First, contact. Second, roughness. I mean, the surface must be rough. It must be having contact. And third is called, what is that called? The relative tendency of motion. Okay. What we call the relative
tendency.
tendency of motion. That's very common sense. I mean, you can understand this. Yeah. So just because if you're taking the scotch bite and trying to touch the utensil but not trying to move at all, do you feel any resistance? Hmm? You're not trying to move your hand. So you're simply touching the utensil at one point. Do you feel friction?
No, sir.
No, sir.
So friction only comes when the tendency is also there. So the tendency is very, very crucial. Imagine a situation. Let's say I have a frictionless ground. So ground is frictionless. And then you take two blocks. You kick both the blocks simultaneously in such a way. I mean, how this is achieved, that's not your concern, and that should not be your concern. You should only think this way, that the blocks are kicked in such a way that both attain the same velocity. And ground is offering nothing, so it's a frictionless, it's smooth surface. Now, there is a concept of inertia. So inertia will let you continue the way you're moving. So block and the plank, or the bigger block, you can say, both are moving with the same speed. Are they trying to create a relative motion? Okay. Is the upper block trying to move relative to the lower block, or vice versa? Tell me yes or no. Do you see the tendency of relative motion? Do you see the tendency of relative motion here? Yes or no?
Yes, sir.
You see. So you see the tendency of relative motion between which two blocks, or which two surface, not block. Tell me.
So the smooth surface and the block.
So if it is a smooth surface, then even though there is a relative motion, will it have any friction?
No friction.
Now talk about the between the blocks. So there is one more contact surface between the blocks, right? So M1, M2 are also touching, and you can see the surface here, right? Now only focus on the contact surfaces. Do you see the tendency of a relative motion here?
No, sir.
Yes or no? Everyone tell me. Do you guys see the tendency of a relative motion?
No, sir.
So will they exert friction force even though it's rough? Will there be any friction?
No, sir.
No.
So definitely there is no friction. So roughness. So here we say that this roughness is here, but roughness is not the sole criteria. So what are the elements of deciding friction? What we should look for? We should look for three things. First, are they in physical contact? Now the question is, what is the mathematical definition of physical contact? What is the mathematical definition of physical contact? it is not about the visual perception. It is only about the the normal reaction mechanism. So when we say that the two surfaces are in physical contact, it means the normal between them must be non-zero. When you say normal is zero, it means it may visually look touching each other, but that's not your concern. In concept of physics, it's not touching. Is this clear what I'm saying?
Yes.
So what are the three key elements for friction force to act? The three key concepts. Tell me.
So physical contact, force, and relative tendency of motion.
Correct. Physical contact. So for friction to act, we need a physical contact, we need a roughness. And then third thing which we need is called a relative tendency of motion of surfaces in contact, not the body. I mean, what is happening? Of course, in this chapter, you're not dealing with body, or dealing with blocks, which looks like a body which can only move forward or backward, up or down, or maybe like in one dimension. So you will get more intuition in the chapter of rotational dynamics, where the body will have a very complex motion. It can rotate also, it can translate also. So those kind of motion we are not discussing right now. We are only talking about the linear or translatory motion or rectilinear motion, to be seen. So condition, if I talk about the condition for friction, condition for friction, the first will be, tell me quickly.
Physical contact.
Physical contact, quickly. Second will be
Roughness.
Roughness.
roughness of surfaces in contact, roughness of surfaces in contact. Third,
Relative motion of surfaces in contact.
a relative tendency of motion between the surfaces. So you can say relative tendency of motion, or you can say relative motion between the surfaces in contact. So these are the conditions. Okay, this is what you need to remember. That's very important for you. Okay. Now the question is how to decide the tendency. What is the thumb rule to understand tendency? This is a very famous question. And the answer is very simple. So how you're going to decide the tendency of a relative motion? Sorry, I should have written a relative tendency of motion. Just a moment. I'll change this. Okay. So how to decide a relative tendency of motion?
So if there is any presence of unbalanced force in the body.
Correct. So it means to understand the relative tendency of motion, you have to start with this assumption. Let's say there is no friction. I mean, how the things would have behaved in the absence of friction. So you imagine that if I remove the friction from the entire situation, then what would be the motion? And from there we come back and derive it. Okay. So the answer is very simple. Assume there is no friction, then look for the tendency, and from there you can derive it. See, this is the assumption. I mean, of course, friction may be acting in the question, but we can remove the friction mentally, and then we check that what it can do if there is no friction, how it would behave, how it will move. So this is taken as a thumb rule in physics, that to find the relative tendency of motion, we simply assume there is no friction, and then we check the relative tendency. And then we bring back the friction in the ABD to oppose that relative tendency. Okay. So let me put it. So to find the relative tendency of motion, we first assume there is no friction, and then we check the probable direction of relative motion, and accordingly we apply friction to oppose that tendency. Okay. And where we apply the friction force, it is always applied on the surface, not on the body. So we apply on the surface and contact. So friction force is always applied parallel to surfaces in contact. So normal you apply normal, friction you apply tangential. So that's the whole idea. It is always applied parallel to the surfaces in contact. And friction will only oppose. Friction will oppose the relative tendency of motion of surfaces in contact. Okay. So these are the simple key points that one should remember, and I think this is not difficult. Okay, so this is clear how to apply the tendency. Now we'll do some experiment, and we'll define the the mathematical definition of friction. So this experiment is very practical experiment. So we have a block. This block is attached to a string. This string is passing over a pulley. Sorry. And then here we suspend a pan. So this is the pan. Now this pan I'm going to assume as massless. So there is no mass of the pan. So let's say block will have some mass, and of course the surface below the block is rough. So imagine it's a rough surface. So we are not supposed to draw it visually that it's rough. I mean, if I'm saying rough, assume it's rough. How and why should not be, the question. It is rough, it is rough. So now the block is on a rough surface, and this pan I take essentially massless. I'm assuming there is no mass. Okay. So right now, what is the tension on this string? If I theoretically say the pan is massless, what is the tension in the string? Tell me. Tell me, guys. Am I audible? Hello, hello, hello.
Yes, sir.
Pan is massless.
Yeah, I'm saying that if the the pan is assumed to be massless, then what do you think? What will be the tension in the string as of now?
So no
G.
tension.
It will be 0. So what is the force acting on the block because of the string?
0.
0. So the tendency, is there any tendency for the block to move as of now?
No.
So do you think friction will act on the block?
No, sir.
No, very good. Now, so imagine you start pouring. You start pouring sand. Okay. So when you start pouring the sand on this pan slowly, I mean, you're doing in a very slow pace. Maybe you're putting 1 pinch of sand at one time, few milligrams. So whatever sand has been put on the pan, the sand will have the tendency to fall downward, right? Because of gravity, yes or no? Tell me quickly, yes or
Yes.
no? But who will stop the sand to go down?
Mass of the block.
No, no. It is the base of the pan. The first thing is the base, no? That
Yes.
is stopping you physically. See, you have to think step by step. The first is gravity is trying to pull the sand. The base of the pan comes in its way. And so the pan will try to stop it. In a way, pan will be pushed downward. But as the pan will try to move down, who will stop or who will oppose? So who will stop or prevent the pan to go down?
Save the block.
No, again, you're just thinking wrongly. It is the tension force which will develop.
Yes, sir. Tension.
So there are many steps, right? First, first gravity is pulling it, then pan is stopping, the pan will try to move, then tension will stop. And now the tension will go here. So if the block is not moving, then what will happen? Who will stop the block? So which force will stop the block from going right?
Friction.
So how the friction should act on the block?
So towards left.
So friction will act on the block towards left of what magnitude?
T.
Very good. So what will happen if you start, if you plot a graph between the friction developed between the surfaces of block and the table versus the tension developed. in the string. So as T will grow, F will grow, isn't it? So both will grow, not just proportionally, but equally. So how the graph will look like? Tell me. So as you keep on pouring the sand, then the tension will keep on growing, and so the friction has to grow to keep the block at rest. So if you plot the graph of F versus T, then what do you think? How the graph will look like? Hello.
So a straight line,
Yeah, straight line passing through.
origin,
And at what angle? Like this, like this, like this. What do you think?
so 45 degrees.
Exactly 45 in this case, because the way we have drawn the diagram. So as T will grow, F will grow, T will grow, F will grow, T will grow, F will grow. But there is a limitation. F cannot grow beyond certain limit. There is a problem. So the growth cannot occur infinitely. It will stop something because of some physical limitation. And the limitation is called the limiting friction. So we write as F S because it's static max. So we write as Fs max, but we call this as so friction will grow from here to here. But once you try to exceed the tension beyond this limit, the cold welding, all the gluey stuff, the cold welding will be broken. Suddenly, all the bond breaks. And then it starts the actual motion. Now it's the journey between the mountain and the inverted mountain. The mountain on the table and the inverted mountain on the block. And they start, kind of breaking each other. They tear apart the surface. At a micro level, there is a lot of destruction happening. The microscopic collisions are happening. So the mountains are hitting each other and tearing it apart. Surface is getting rubbed away slowly. And the moment this bond breaks, the opposition, which is we are also going to term as friction, but this is a different thing. So the opposition, because of the roughness of the surface, the irregularity of the surface, the irregularity creates something. And what it creates, we call kinetic friction. This opposition is of different nature, but because at the end it's opposing, and these are micro scale kind of destruction happening. So you can imagine that the mountain range and the inverted mountain range are trying to move against each other. So there is opposition for sure, and that opposition we are going to term as what? We are going to term as the kinetic friction. Is this clear? And now once the motion begins, the two surfaces will maintain that opposition, because if the surfaces are kind of having uniform irregularity, or the roughness is kind of uniform, it's not changing as you move, the friction will become constant in value. It will never change. It will have only one value. And once you break it, there is a sudden dip in the frictional force value. So there is a dip, and this dip we call kink. Okay, this is called kink. So there is a sudden fall of the value. It may exaggerate. Okay, this exaggerate the value, and then the new kind of friction, which we call kinetic friction, will continue acting, but with the same value everywhere. This will not change. As long as the surface is having the similar nature, its value remains same. And therefore, this value is called kinetic friction. So we write as F K. So there is a very common question that which friction is a bigger friction? Is static or kinetic? The answer is we can't compare. We cannot compare the static with kinetic because static can have any value from here to here. So static is less than also and more than also kinetic. But we can create a better question by asking that which friction is bigger, limiting or kinetic? So the answer will be hello. Which friction is bigger, limiting or kinetic?
So limiting.
Yeah. So can we compare the static and kinetic?
No, sir.
So what we can compare?
Limiting and kinetic.
Right. Very good. So we can only compare the limiting and kinetic friction. We can't compare the static versus kinetic. So what we can say about the static? We say static is called the self-adjusting frictional force. It can adjust its value as per the applied force. I mean, it can act to certain range. So if things are within that range, it can hold the object by creating as per the demand force. So limiting is like your upper limit that you can create. Okay. And any force which is beyond the limiting will start the motion. But once it will start the motion, the frictional value will drop. But you must remember that to start the motion, we have to overcome what? When motion will start. Okay, if I apply force, let's say put some value. Let's say the kinetic friction is, let's say, 100 Newton and limiting, let's say 110 Newton. Let's say. If I apply a force of 105 Newton, motion will start, yes or no?
No, sir.
What will happen if I apply 105 Newton force? So to begin the motion, I must apply how much force? Minimum?
110.
Yeah. So I must apply 110 Newton, then I can expect motion. But once the motion starts, the force that we need to, apply in order to maintain the motion against the friction is only 100. So my force is actually bigger than the kinetic friction. So it will accelerate now. So what we need to realize or understand is that although kinetic is less than static, but the kinetic will never be achieved once unless we are not overcoming the limiting friction. So that's why there is a question. Why it is easier to maintain the motion than to begin the motion? So what is more difficult, to start the motion or to continue the motion?
To start.
And you might have experienced this if you have pulled some heavy table, okay, at your native place where you have the grandfather table, a big table, very heavy. If you try to move, it will not move. It's very difficult. But if you kind of apply force beyond somewhere, it will suddenly start moving with ease. So in many situations, if you try to drag some very heavy objects, it's difficult to start. But once you set this into motion, then you can actually pull it easily. And the answer is obvious. It is the static which we need to overcome in order to start. But once we start, it is the kinetic which we need to overcome. And because the limiting is more than the kinetic, so is the answer. The answer is clear. Question is clear what I asked?
Yes.
So what I asked? Why it is easier to continue the motion than to begin the motion, right?
Yes.
And the answer is, okay, I hope you understand. Now the question is, What are the formula for these two, the limiting and the static? So we have something called laws of friction. So the first is called laws of limiting friction. We don't have law for static. We have only law for the limiting friction. So laws of limiting friction. First of all, we are learning something called solid friction. We do have the liquid friction, gaseous friction. Their definitions, their laws are different, but in the world of solid objects, the laws are different. So you have to only remember that what you are learning right now is solid friction, not the fluid friction. And of course, the fluid friction is a part of our JEE syllabus. We have to study, which you will study eventually. Okay. So the laws of limiting friction is very simple. The first law is the frictional force value, the magnitude of frictional force does not depend on area of visible contact in a way. If you have an object, let's say if I give you a cuboidal shape object, so I can keep like this, I can keep like this also, right? I can keep like this also. There are many ways of putting it right. So same block can be put on the ground in multiple ways. Okay. And in as you change the way of putting it, what will happen? The area will change, yes or no? So ground will have the different contact area. So it will contact or touch the ground over a bigger surface or a smaller surface. Now the law says that okay, it doesn't matter how you put, the friction force will be same in each case. So gravity force, the force of gravity is acting on each brick in the same fashion. MG. So what will be the normal reaction in each case? Tell me. So normal in each case will be same as mg, yes or no? So if the brick is at rest, then the normal will be same as mg.
Yes, sir.
So the law says that okay, the friction force does not depend on area of contact. It is clear. And second is what? the magnitude of frictional force is proportional to so mathematically Fs max is proportional to the normal reaction. Okay. Because Fs max is proportional to normal reaction, so Fs max will be equal to some constant into n, right? This constant we write as so this constant is called mu s, and there's a name for it. Anybody knows what is the mu s called? What mu s is called? Coefficient of it is called coefficient of static friction. Now you may be confused that is it static? No, it is called because even the limiting is static. So the mu s is symbol only, and it simply says that how much friction you can develop per unit normal reaction. So it means if I create a normal reaction of 1 Newton, then the friction will develop is mu s. That's it. So for 2 Newton, it is twice of this value. For 3 Newton, it is 3 times. For 10 Newton, it is 10 times. So if the normal is equals to mg, it is mg times. Okay. So is this clear, guys? Hello, clear?
Yes, sir.
So you can also experience like the normal will increase the friction. How? So if you are touching the ground while sitting on your chair, how many are touching the ground? Your foot is touching the floor. Anyone? Is your foot touching the floor?
Yes, sir.
Can you move your foot over the tiles, the floor? Can you move? Of course, I think you can move, right? Easily
Yes, sir.
to and fro. Now what you can do is now press your knees against the floor. Press as hard as possible and try to move. And see, check, is it getting difficult or it's okay?
It's difficult.
So more you press, more difficult, right?
Yes, sir.
So as the normal will increase, the resistance will increase. If you try to create a relative tendency and for creating more normal reaction, it will change, right? So it is obvious that friction will grow with normal, yes or no?
Yes, sir.
No. So now we can go to the second one, which is laws of kinetic friction. Theoretically, there are many differences, but mathematically, it's very simple. This chapter is difficult if you do not understand concept, the theory. But it is easy if you don't know the concept. It's just it will increase the writing part. So you have to do more calculation. You have to add one extra force in laws of motion. The rest remains same. So laws of kinetic friction. It's a similar. The first law is same as the earlier case. So magnitude of what was the first law? So this is the A part. And the B part is what? Same. Magnitude of which means directly so you can also do the same thing mathematically. So what you can say mathematically? AFK is proportional to N. And so FK equals to how much? So the symbolic change will be there. So what is mu k called? Coefficient of which friction?
Kinetic friction.
And what we must remember, let me put it in bracket, that mu s and mu k, which one is bigger? Can we compare these two?
No, sir.
Why no? For a given surface, the mu s is going to be always bigger than mu k theoretical. Tell me why. Tell me why. Because the limiting, mu s comes in limiting actually. Mu s does not come in static. See, first of all, there is no formula for static friction. We don't have any formula for static friction. Understood? So we have only formula for the limiting and kinetic. The static is as per the requirement. It can create its value between the 0 and the limiting value. Okay. Is this clear why it is so? Why mu is more than mu k? Tell me, guys, is this clear? Yes or no?
Yes, sir.
Yes, sir.
You understand what I'm saying? So mu(s) is more than mu k is always true, but saying that fs is more than fk, is it true? Is this correct? Tell me yes or no. We cannot say with confidence that okay, this is always bigger. It could be anything. So fs can have any value. Fs always lies from where to where? From 0 to so the value of fs can have any value from 0 up to so this is cannot be compared. Hello, is this clear? Yes or no?
Yes, sir.
So first of all, you must remember because this is a very common mistake. People think that fs is mu(s) into n. No, fs is not mu(s) into n. Fs having there's no formula for fs. Fs is like the namak swadanusar. You create or the surface creates as much as it's required. For example, if you have a 100 rupee note, you go to market to eat pani puri, and the pani puri will cost you let's say 40 rupees. Will you pay 100 or will you pay 40? How much will you pay?
Sir, 40.
Hmm?
Sir, 40.
40. So what is 100? So 100 is like the limiting friction. Okay, that you can do. I mean, if required, you can create that much. But if the requirement is only 40, then you will pay 40. That's like a static friction. So limiting gives you the limit, like what you can create, how much you can go up to. So static friction having no formula. It is calculated from the FBD only. Static is always derived from the writing the laws of motion. You cannot have a formula for it. But Fs max is having formula. If I know that it is limiting which is acting, then I can convert it. Or you can use that formula mu(s) into n. Tell me, any doubt in this? Anyone having any doubt so far?
No, sir.
Okay. So one thing is skill that if you want to solve question of friction, in the ABD so far, the normal was not required, but now we need normal. So we'll do some simple practice to write the direction of friction. Finding direction finding direction of friction. You can see there are many blocks, 1, 2, 3, 4. And because gravity is acting, so normal will be there between every pair of surface, isn't it? And imagine all surfaces are rough. So this is moving with a speed of 2 meters per second. This 4 meters per second. This 3 meters per second. This. Draw the direction of friction force on each block, on each surface for every block. So how many blocks we have here? So we have 4 blocks. So we'll start with the first block. Okay, tell me. So first of all, how many surfaces of one is making contact with other surface?
Sir, only one.
Only one. So how many frictional forces we have to draw here? Only one friction.
Yes, sir.
So what will be the direction of friction on 1 kg block? On the first block? Forward, backward, right, left. What if? Tell me, Rugved.
Backward,
Backward. Why backward?
because it is moving forward with 2 meters per second.
But what I taught you? I thought that it depends on the relative motion, right? Not the motion. You're moving on a surface which is moving faster than you. So for that surface, are you moving forward or backward? See, if you want to find the friction on one, only ask two. Because friction force on one will be applied by two, not by one itself, right?
Yes.
So you will ask person two, and he will tell you that how one is moving. So in the frame of two, how one is trying to move? Forward or backward? Right or left?
Backward, left.
So because one is trying to go left, how the friction should act?
Right.
Very good. Tell me, guys, do you realize this? Siddhant, questions are telling.
Yes, sir.
Yes, sir.
So it's very simple. I can do a simple friction. I can name it F1. But once I draw the friction on any one surface, the immediate surface will have the same value in the opposite direction, isn't it? So we need not to worry much. For two, I know the F1 must be acting in which direction.
Left.
So it is called the action reaction pair because it's the internal force, isn't it? For these two blocks, this is internal force. And we know that the internal force comes into pairs. So if F1 is acting right on the first, it must act left on the two, the immediate. Is this clear? Yes or no? But 2 is also having one more surface. Do you realize this? So 2 is also making some contact where? Tell me, guys, where the 2 is making contact with?
With the upper surface of 3.
Very good. Then ask 3. How 2 is moving? What is the reply of 3? What 3 will tell you?
2 is moving towards its right.
So 3 will tell that 2 is moving towards right. So how 3 will apply friction force on 2?
Towards left.
Very good. So now this is obvious. That the next friction will be also at backward equals to, let's name it different because this is a different pair of surface. So we have to change the name as per the pair will change. And now we come to the block number 3. So once you come to the block number 3, without any analysis, you can say the F2 will act like this, correct? Tell me. Now 3 will have one more surface. And what do you think? How 3 is going over the 4? Ask 4. See, if you want to find friction on 3, you should ask the person who will apply. So you never apply force on yourself. So you have to ask the other. So 4 will tell. So what 4 is telling? How
3
3 is
will
moving?
move towards the right,
So how the friction will act?
left.
And now we can see this is F3. And then comes the last one. The 4th. So F3 will be forward. And ground will always say it's going right. So ground friction will be which direction? Okay. So ground friction will be like this, F4. And of course, I mean, there is no need to show the friction on the ground. Ground is also experiencing friction, but that is not required. So we only draw for the blocks which will be part of motion. If something is ground is also experiencing, no need to represent. You can ignore it. Do you realize the process of writing the friction? Yes or no? Tell me.
Yes.
Yes.
But every time you will not get this kind of numerical value of motion. I mean, they will not tell you. So this is even more interesting and challenging. That how to draw the friction. Because as a beginner, let me tell you, I fought it really hard to master this friction. And it eventually came, but took me 1 month to figure it out. So I solved almost all questions, but still in some question I used to get stuck. And then I decoded the entire friction. 1 month of struggle to decode friction. When you really want to understand something, it happens to person. If you want to understand something, the nature will kind of conspire to help you. But the first condition is, do you really want to understand something in your life? Now, do you see any motion here? Do you see any tendency here? Tell me yes or no.
No, sir.
You see nothing here. So what about the friction force? It is going to be 0 everywhere. Yes or no?
Yes, sir.
So what you do is you start applying a force. You kind of drive the block. You apply force on this, the upper mass. All surfaces are now. If the world is frictionless, because that is how we start, right? We say that, okay, assume there is no friction. If there is no friction, then how M1 will try to move? What will be the tendency of motion of M1? Come on, guys. You are applying force F on the M1, then how it will move?
Towards the right.
So if I assume there is no friction, then the only way to move is right. Correct? Yes or no?
Yes.
Yes, sir.
So now you know the tendency, no? You know the tendency, it will move towards right, given a choice. I mean, given if there is no friction, it will move like this. And because you know the tendency, so friction is there to oppose the tendency. How friction will act on M1? And see, friction M1 is moving right over the M2 surface, as per the idea. So how friction will act on M1?
Towards
me.
the left.
Towards the left. So similarly, can you draw the ABD of M1, M2, M3 with the normal gravity and friction? Everyone, please draw it and send it to me. And don't write FSF, just write F1, F2, F3, as many pair as you have to write. Tell me the answer. I mean, not tell me, just draw the ABD with friction ABD and send it to me. Okay, can we say that friction will be static or kinetic? Is it possible to say? Looking at this diagram,
No, sir.
very good. We can't say. Okay, person. So when you draw the friction, draw near the surface. Don't draw this way. This doesn't look nice. The rest is okay. Uh,
Sir, I forgot to write M1 plus M2 plus M3G. Yeah.
no, you're not supposed to write that also. And all these things are wrong. I mean, see, gravity cannot apply force. Your gravity will not act on my on myself. So your gravity is your gravity. My gravity is my gravity. So why N1? Okay, why M1 plus M2 G you have written? I don't know. If your mass is M2, then how much gravity will act on you? Tell me.
M2G.
So why you written M1 plus M2 into G? Tell me the reason. There is no logic, no? So the essence of ABD is lost here. And this is a very common mistake. I mean, what you're committing is the world famous mistake. I mean, this relation comes really late. That what you're writing is something, your own intuition, I mean, your own idea of laws of motion. You're not applying the concept. So, I mean, you can explain me like why you wrote M to M2. And in the third diagram, where is the M3G? And also explain why F2 is acting forward on M2. Any guess? You didn't develop any, I mean, you haven't developed any logic. What you're doing is something like what your mind says. Okay, I can do this. There is no analysis in this ABD. I mean, you haven't analyzed anything. Or have you analyzed this?
So because F force pulls M1 towards the right, then
F is acting only on M1. What will drive M2? Tell me the answer. F is trying to drive M1. But who will drive M2?
the friction.
And when friction will act on M2, then how M2 will try to move? What will be its tendency? Siddhant, you have to draw for each block, not one block. Each block separate. I would like to see. Yes, person, sir. Are you getting it? What I'm saying? There is something called driving force. Everything is driven by someone. So you start, you create the drive at some location, which in turn creates some effect, and the effect will drive the next. See, F is not driving everyone. F is driving the object on which it is acting. And if there is a connection, if there is a contact force, then that contact force will drive the next one. So who is driving M1? The answer is correct. M1 is driven by F. So there you create the tendency. And therefore on M1, the applied force is this and the friction will be like this. And then the normal reaction and so on. So I have to say this is normal. Let's say go upward and that's easy. And then M1. Why it is so difficult? I don't understand. Or maybe let me pretend that okay, I can understand. It's difficult. So similarly, if you do the M2 ABD, so from action reaction pair, if F1 is acting left, then F1 on the M2 will act in which direction?
Right.
So you need to understand that this new F1, because of friction, this F1 will be the driving force for M2. If I make the friction 0 between M1 and M2, only M1 will move. M2 will never ever move at all. Why M2 will move if there is no friction, if there is no force? So now M2 and the below the block M3, if there is a friction, then something will happen. Now F1 will drive M2 in which direction?
Right.
So the tendency of M2 is to move right over the M3 surface, correct?
Yes, sir.
So how the friction will act on M2?
Towards the left.
So you have to draw towards left now. And what else? So N1 will come act like here, N1 will act here. The action reaction pair, and then M2G will also act here. And the normal from the M3 will also act here. So we can call this as N2. Okay, it's easy if I draw one below the other, then I think you can understand better. Let me draw. So the idea is the normal is acting. See, that's why I say if you draw exact picture, you can get better idea. So normal N1 is acting here, right? And this N1 will act on the below surface. So do you transfer your weight or do you transfer the normal reaction? What do you transfer?
Normal.
Yeah, so always remember you only transfer. See, we have two types of force, contact and non-contact. So don't try to deviate from the laws. I mean, that's why I say it is really difficult to realize what is being taught. You may hear, you may listen to it, you may understand also, but you don't realize. And all the root of all mistake is the lack of realization. What we are doing, we don't know. We are doing something like blindly following some hypothetical idea. Sometimes that gives you the answer. Sometimes it doesn't give you the answer. Because realization comes when you spend some time with it and you try to realize it. You have that tendency to know. You want to realize and make sure that you don't need to do this again. I mean, you want to learn only once, but in the right way. Okay. So F1 will act in which direction? Now F1 becomes the driving force for M2, which will try to drive it towards the right, and therefore it will be opposed by the M3. And now this is third force. And then there's a normal action here. Let's call N2. And this normal will act on the next guy, the next block. And M3 is having no force because N2 will not drive, but F3 will drive M3 and of course towards right. And so if ground is also rough, you will apply the fourth force. And then there's a normal there, which is N3. Okay. And there is no formula because I don't know whether it's moving or is it at rest. I have no clue actually. So I will only follow the rules of physics. I will not try to create my own physics. So as a beginner, it's very important that more than solving problem, you spend some time in realizing the situation, realizing the theory first, and make sure that you really understand it. Don't do like like some steps is being kind of mugged by the students. Someone is teaching dance 1 2 3 4 1 2 3 4 and you learn the 1 2 3 that's it. And it is being like kind of dictated. Like you have to think dance, go right, go left, turn back, jump, and you're just repeating it. So you're not learning dance. You're mugging the dance. And now it's a fashion nowadays, in every metro city, every kind of kids are forced by parents, you must learn dance and music, even though they are not interested. And then the teacher will come there, 1 2 3 4 1 2 3 4. And then someone will appreciate, oh my god, you're dancing really good. I mean, are you really dancing? Or are you simply following the steps? Do you have your own realization? Now, those with their own relation, they become the choreographer because they realize that what is good, what is bad, how it should go. So that's the difference between us only dancer and one who knows the choreography also. So in physics also, there's the same thing. I mean, you're solving question because it is being said to you that do this way, or you're solving because you have realized it that this is the way I can do, and this is also a way I can do. So I should turn and jump or jump and turn. Which one is possible? Can you jump and turn? Keeping your body vertical?
No, sir.
No. So that's theory. You create the rotational effect while on the ground, then you jump so that when you are in the air, then inertia will keep you rotating forever. Then you land back to the ground. Then you drive the force from the friction actually. And even jumping is a very nice physics, like how people jump. And there was a question in JEE-Mains long time back, 10 years back. It was based on jumping only, like how you jump. So do you realize that how you jump? Can you jump if the normal acting on your foot is equals to your weight? So do one thing, stand for some moment and then jump and see the difference, what you did to jump. No idea. Tell me how you will jump. Okay, you jumped. You realize how you jumped?
Yes.
Tell me what you realize. Share with others.
So when you
So
jump,
yeah. So what do you exactly do to jump?
so you bend your knees so that you exert, you
Yeah. So you
apply
actually
force.
go down, right? Your body weight goes down, right?
Yes.
Okay, is this clear, guys? How it is happening?
Yes, sir.
So you have to think about the driving force. See, driving force can drive only on the object it is connected. And then you have to go through the origin, the trigger point to other object. And this is the modus operandi of every question. And that's why it's called difficult. So let's say if I change the driving location, if I just, bring the force instead of the first block, if it comes to the second block. And now this is the real challenge for you guys. So can you really decode this? So now the force is acting here. And now I have shifted the driving block, the moving block. So how friction you will draw for each block, M2, M3, M1. And please do it and send it to me. I would really like to see and do this way, the way I have done, proper. See, M1 G is not, part of the weight of this. Okay, I have missed this M2 G. And I have also missed M3G, my bad. The N1 is getting transferred. It is the N1 which comes to you. And luckily, later on, you come to know or realize that N1 is equal to M1G. That's why the N1 will add to the existing weight, which is luckily equal to M1G. That's why it is M1 plus M2 into G, this N2. But this is not the way you will think. You will think this way, the way I have explained. Because that way of thinking will create a lot of mistake if the motion will start. If I put the same thing in elevator, which is going down with acceleration A, this idea will flop. But what I have done is always correct. Okay, so draw this ABD and send it to everyone. And imagine, see, that's the process same. If there is no friction, what will happen? Then think about it. Then draw the ABD for each block, each surface. Siddhant, it's absolutely correct. Very good. Well done. So Rugved, tell me, like for M2 block, how many surfaces do you see?
2
And how many friction you have shown in your diagram?
and
Hmm?
1.
So that's incorrect, no? Change
Yes.
it. Draw once again. Okay, person. So this again absolutely correct. So that's correct. No problem. Well done. So you realize, right, how to proceed if I shift the driving agent, right? In physics,
Yes.
there is a concept of driving agent, someone who drives the entire motion. And see, it is the connection which, helps in transferring the force. So force is not, kind of, you apply on one and it goes to the two. No. So that is called the, some sort of constraint. So when you ride a bicycle, what you don't realize, the bicycle will have a chassis, right? Every vehicle will have a chassis, which is a rigid support. And that how sturdy the chassis is will determine that how easily the force can transmit from the. So when you apply brake, the brakes are applied on a wheel. So the wheel may stop, but who will stop the other part of the bicycle? The whole geometric construct which you see, the pipes, the rod, and front wheel. And then you will realize that the effect is kind of transferred. So one stops, which in turn stops the other part. And so the entire cycle comes to rest. And the idea is cycle does not come to rest immediately. I mean, even the front wheel will come to rest, the other part will take some time, which is very small. You don't realize this. It's a fraction of a second. So in future, you come to know that there is something called a wave. So when you kind of stop something, a wave is developed, that wave transmits through the rigid support and it reaches the different part of the car. And it is the travel speed of the wave which will kind of stop the other parts accordingly. And these waves moves really fast. I mean, it's like in a case of solid, it may be moving at a speed of 5,000 meters per second. Now your car is only 5 meters. So in 1 millisecond, it's done. So it is even fraction of millisecond in which everything happens. I mean, this is how the world works. So everything is getting stopped because of some force they, experiences eventually. In case of rigid structures in which everything is connected, rigidly, they are either welded together or something like this, there the welding is creating that force. If you look at one single piece of object, a solid object, the force transmits layer by layer actually. And then it goes from the front to the back. If I hit the front, the force will go to the back layer by layer, one layer, the next layer, the next layer, the next layer, the next layer. So there is a transmission of force. So in case of disconnected object, the friction acts as that glue, which helps in transferring the force from one to the other. Okay. And if glue is really strong, then it will not move also. It can move together. So system can move separately. System can move as one object. The friction is the invisible glue. The glue can be weaker, so it will create the relative motion. If it is stronger, it will take it together. So for example, you can see that in the case 2, so driving force is M2, you apply force F, so definitely it will create a friction here and here, because that both surface will try to go, it will oppose in the opposite direction. And so M1 will experience the friction here. In fact, M1 will be driven forward. You can clearly see the same friction is driving M1 forward. I mean, not forward, means towards the right. And F2 is driving or will try to drive M3 towards the right. And so the ground will apply force backward. I think this you have missed. Someone has missed. Okay. Is this clear? What is happening? And then of course the normal is there. The normal is there, of course, and mg is there. That I haven't shown, but you can draw it. So the starting point of tendency will be the force which you apply, if not gravity, because in most of the cases gravity is the invisible agent which always try to drive things. But when gravity fails to drive something, then we have to look for other forces. For example, here gravity is acting this way, so the gravity cannot drive or cannot create the tendency in this case. But in many situations, gravity does create the tendency. So that's very interesting. Is this clear? Hello, hello.
Yes, sir.
So we'll try to understand through a very complex problem. So we have a block, a really big block. Okay. And now there is a pulley which is kind of firmly attached to the block. I mean, when you connect a pulley with block completely, it's a block and the pulley are one object. It's not separate. So whatever you apply on the pulley will transfer to the block without any change. Okay. And the pulley on the right is kind of attached to this wall. So your job is simple. If I release the system, all surfaces are rough. All surfaces are rough. Okay. So now can you identify the driving agent here? Who will drive the motion? Who will start the motion? No idea. Think about it.
Sir, the small M block.
Hmm? Yes,
So
please tell me.
mg,
Yes, MG.
MG, which MG? Small MG, capital MG.
small
Small
mg.
MG.
Very good. So it is the gravity on the smaller block which is the driving agent, because that will let it to go down, and which in turn will create all the motion. So driving force you can see, so you know that how the motion will begin. And once the block will go down, what do you think? How the how the big block will move? Right, left, what do you think?
Right.
Right. And how many surfaces in contact do you see here?
So 1.
So 3. So 2.
How many? So how many sees only one? Persons are why you see only one? So you see only one pair of surface in contact?
No, sir, 2.
Oh, very good. And you can see the driving agent and the motion. So can you draw the ABD for the block and the block? I mean, is small and the big block. And remember, if pulley is part of the block, then you have to draw the pulley with block together and then draw the ABD. Okay, so the object which is connected must be taken into consideration while drawing the ABD. You're not supposed to remove the pulley. You have to draw the force on the pulley, which is force on the block itself. If it is connected, that's the rule. So here, this pulley is part of block, right? So when you draw the ABD of bigger block, keep the pulley the way it is, and then draw the ABD. So draw all ABD, write all friction forces or whatever forces, and send it to me. So the friction force you haven't shown anywhere. Eh? That's the biggest mistake. And separate the blocks. Don't draw the block together. I would like to see the force on the bigger block and small block separately. So do it again. Now this time in Siddharth, you have removed the pulley, right? That's mistake.
So like I have written tension mentioned.
No, but the tension on the pulley is not there, no? The tension force on the pulley is also tension on the block, right?
Yes. So but in FPD, do we draw the pulleys?
Yeah, in FBD, if pulley is attached to an object, then we draw the FBD of pulley itself.
Okay, sir.
Yeah. Because both will move together, no? Are they separate? The answer is no. They move together, they remain together. So the force acting on the pulley is getting transferred to the bigger block directly. Isn't it? Just add that value. I think you are very close. You have missed so many forces. There are two surfaces, but you have written only one friction. Why? And the pool and the pulley is part of the big block. You have attached the pulley with a small block.
Sorry,
Why?
sir.
Change everything. So many mistakes. Huh? Yes, now it's correct. Very good. Rugved, yeah, I was asking you only. So because pulley is part of the bigger block, tension always act away from the object or towards the object.
Away.
And what you have done? Can you check? So how you have drawn the arrow of the tension? Do you
Yes.
realize this?
Yes.
Second mistake. The normal force will be how many? On the vertical portion? 1 or 2?
1,
And how many normal you have shown?
2,
Change it. No? If you know it's incorrect, then change it. Prasansha, do it fast. So, okay, question. Again, you have made the same mistake, Prasansha. That the tension on the pulley will be away from pulley or towards the pulley. Tell me. How tension will act? For the pulley to act like this, no? Okay, so I'll do separately only. Tension always act away from the object connected. Okay. How normal will act right on the big block? Tell me. Who will apply force from the left side? I don't understand. Explain to me. Yes, Rugved, I'm asking you. The block will press the bigger block towards left or right. How it will press? Normal is a pressing force, right? So how you are going to press this? Right or left?
Left
And how you have drawn? Check.
towards right.
Correct it. Correct it. And also you have missed the normal from the bottom. So there are many things which you have missed. And don't worry, it will take some time. ABD is not that easy. And draw properly. I mean, this is don't draw the way you want. Huh? Always show that friction is acting over the surface. So draw like this, tangentially. These are some good practices. I mean, if you have this practice, it will help you a lot. If you draw the way you want, that's not good. Because when we draw the ABD, we actually convey a lot of messages. Okay.
Yes, sir.
So more accurate the message, better will be for you to write the equation and solve it. And this is not okay. I mean, it's not only like you can listen to my lecture and will become genius. Nothing like this. This will happen ever in your life. So you have to really, kind of grind yourself as much as possible. You can't, bring excuse that you are busy or you're something. You have many homework to do. And if you're doing so much thing, then what is the improvement? So you must, show that you're improving day by day. Your marks are going higher. You're able to understand things in class also. Many times I have seen that when you join a secondary, you join some tuition or go to some other teacher, you stop learning at the first place, which is also wrong. If you're going to coaching classes also, coming to here also, be as much alert you're here, the similar way there also. You will learn something. And when you come here, then it will actually benefit you. It will help you, getting the things in an easier fashion. So don't, kind of relax yourself. Okay, this is not good. I will only learn there. Those attitudes are not good. It's harmful. It will be like loss making decision. You don't like a subject, then you start, you stop listening to teacher. So rather than finding the solution, we stop learning. And in a way, we harm ourselves and we feel that, okay, we are justifying the mistake of teacher. You are aggravating your problems actually. Okay. So wherever you're going there, if you're going to multiple places, then be very alert everywhere because there is something to learn everywhere. So whoever is teaching you, he must be knowing something at least more than you. So he can teach you something. Keep that attitude in mind. Okay. Learn everywhere. Don't lose the opportunity which you have available. Listen very carefully. The listening is very, very important. Develop these basic traits. Okay. If you really want to excel in your life, in academics. Of course, nowadays there are many YouTubers, they are earning crores, but they failed in the subject which they thought of learning. So you may say that they are successful, but they are failures in many ways. And if your only aim was, kind of YouTube, so you go there, no, start doing it. The chance of success in any endeavor requires extreme hard work. So those who are very successful, they have put their heart and soul in whatever endeavor they chose. So if someone chose to be YouTuber, they did hell lot of hard work. Okay, so if you think that okay, you can succeed in other domain, and if you do not have the habit of doing the hard work, you will fail everywhere actually. So academics maybe, someone may not have the interest, that's totally okay, acceptable. But whatever you're doing, whatever are your skill set, you must excel there. Let's say you don't like physics, so are you really doing good in maths and chemistry? Or you don't like chemistry, are really doing good in physics and maths and similar? Because you may be weak in one chapter and one particular concept that is not coming to mind easily. But if you're weak in everything, it means you haven't started learning. So what you have missed is the learning process. So that is how we judge, like, how one student is performing good or bad. How we understand that, okay, they are going the right way or the wrong way. So we only check that whether they are able to understand something and replicate, reproduce the concepts, or they have mastered the ideas. They may be getting less marks, then still we are confident, okay, they will qualify. Because we know that it's a long-term game. It's not short-term that today you will not be performing, but still I can see when I give homework in, when I give question in class, what I expect that you will be solving here. Those who try to solve, they're learning. Those who are waiting for the answer, they are still not learning. So the rise of knowledge status will be there only. You will not grow actually if you're only listening, if you're not putting effort even to understand. Or if you have doubt, you're not asking your doubts. You may be saying, oh, I'm scared. For what reason? I'm not going to hit you also. It's very difficult even to hit from here. The worst I can do is I can just throw you out of this lecture. But other than that, I can't do anything. So I'm not going to, do any physical damage. So one should not be scared of. So try to enhance your learning or listening skills. Every definition, every concept uttered by a teacher, try to grab it as much as possible. Make it close to 100%. So ABD is clear? Okay. So before you go, let me give you the last question for practice. From next lecture, we are going to solve question. Because see, what you have done is the base of solving problem. If you know how to do ABD, the next step is easy. I'll tell you how to solve. So the biggest challenge you are overcoming here. So tell me honestly, I think Rugved goes to some coaching, persons also goes to some coaching. Tell me, like, do you really listen there very carefully? And you really try to understand? Tell me honestly. Or you just try to, listen half-heartedly and then leave whatever is happening. Tell me, Rugved, what you do there?
No, sir. I listen carefully. Else the questions, I'm not able to solve the questions if I do not listen carefully.
Okay. So you only listen, you also write something carefully. Do you ask your doubts there?
After lecture.
Okay. Very good. So keep this habit up. I want you all to be always inquisitive, always asking questions. Okay. Now this is the diagram. You can understand the driving force here again, right? Do you see the driving force here? So what is the driving force here? Who will drive this situation? I mean, these two blocks. Tell me. Who will drive? Hello, hello, hello.
The force F.
Correct. Can you draw the ability now? You know how to shut me. So draw the ability. Tell me the answer. Everyone. This is today's last problem. Tomorrow we'll, I mean, next class. Tomorrow is, I think I'll be tomorrow. Yes. Done? Everybody? So what will be the friction force on small m? Any guess? Right or left?
Right.
Right. So normal. And for the bigger block, the friction is going to be left. And one more force we missed. Which force we missed? Can you guess?
Tension.
And tension will act away from the object towards right. And how the friction will act at the bottom of the bigger block? Tell me first. How the friction will act at the bottom, right or left?
Left.
Very good. Very good. So now this is the ABD. This is how we do the friction. So either if you know there is a motion, you can easily write the direction of friction. If you do not know the motion, you have to look for the driver first. Who is the driver? And then from there you could start drawing the diagram and you will come to the end of the ABD. So this is how we draw ABD. This is the difficult part of this chapter. But if you have understood this, practice this a lot, and then you have AC Verma, and there is a chapter called friction. So don't read the AC Verma. Okay. Don't read the question. Just if there is some diagram, simply draw the ABD of those diagrams. No matter what is question written, don't read it. Simply draw it, and next class, before next class, I think you have to send it to me. Only ABD. But I think there are few diagrams. Maybe 6, 7 ABDs are there. I mean, diagrams are there, or maybe 10 max. Take all diagrams and make your own assumption that every surface is rough and everything is can move or may move, and then draw the ABD. Okay, and send it to me. Hopefully, I mean tonight also it's possible. Send it to me tonight or tomorrow. So tomorrow your lecture will be at. I think Sinant is not there, but I think we decide on 10 o'clock, right? 10 o'clock is fine.
I have class till 1:30.
Your class is 1:30. Then I think okay, we'll keep at 3 o'clock.
Okay, sir.